Good morning students, this is Bhavna Sinha, your chemistry teacher, and this is the first video for this week. As you all know, we have started the chapter Some Basic Concepts of Chemistry, and in today's class we are going to discuss about laws of chemical combinations. So let us start laws of chemical combinations. Now first we should know what do we mean when we say laws of chemical combinations. So the combination of elements to form compounds is governed by the following 5 basic laws. That means laws of chemical combinations are those laws which are followed while the formation of compounds by the combination of elements. Now let us see which are the 5 laws. So the first law is law of conservation of mass. The second one is law of definite proportions. Third is law of multiple proportions. Fourth is law of gaseous volume, which is also known as Gay-Lussac's law. Gay-Lussac was the scientist who has given this law, and in his honor only the law is named as Gay-Lussac's law. And the last one is Avogadro's law. So these are the 5 laws which are followed when compounds are being formed by the combination of elements. So how can we define laws of chemical combination? The laws which are followed during the formation of compounds. Okay, the laws which are followed during the formation of compounds are known as laws of chemical combinations. Now let us see the first law, that is law of the conservation of mass. Okay, so let us see what do we mean when we say law of conservation of mass. So the law was established by a French chemist. Okay, the law of conservation of mass was established by a French chemist whose name was Antoine Lavoisier. A stands for Antoine. Okay, so Antoine Lavoisier. And what does this law state? It states that in all physical and chemical changes, the total mass of the reactants is equal to the total mass of the products. What does this law tell us? It tells us that in all physical and chemical changes, the total mass of the reactants is equal to the total mass of the product. Or in other words, what we can say? We can say matter can neither be created nor be destroyed. What we can say? We can say matter can neither be created nor be destroyed. Okay, so there is a experiment which is explained here. Actually, when matter undergoes a physical change. Okay, so let us see what happens. Here you can see when ice is heated or it is provided heat, then it gets converted into water. Ice is in the solid form, and when it is heated or it is brought out of the refrigerator, it takes the heat from the atmosphere and it gets converted into water, which is in the liquid form. Now the amount of ice which was taken to convert into water, the same amount of water we will get after getting converted into the liquid form. That means the amount remains the same. That means the total mass remains the same. Okay, so this is law of conservation of mass. How can we write law of conservation mass? How can we state it? So I am just stating it. It states that the mass is always conserved during any change. Okay, we can state it in this manner also, that the mass is always conserved during any change. Okay, so this is first law, that is law of conservation of mass. Now it is found that there is no change in weight though a physical change has taken place. That means when ice has got converted into water, then change of state has taken place. Solid has got converted into liquid state, but there is no change in the weight or the mass of the object. Okay, so when matter undergoes a chemical change, there is another example where matter is that was an example related to physical change. Now we are going to discuss an example which is a chemical change. So here you can see decomposition of mercuric oxide. So here you can see 100 gram of HgO, that is mercuric oxide, is taken, which is in solid form, and when it undergoes decomposition, then 92.6 gram of Hg in liquid state, mercury in liquid state, is formed, and 1 by 2 of O2 gas is formed, that is 7.4 gram. Hg plus O2 is formed, and 92.6 gram Hg is formed, and 7.4 gram O2 is formed, and when you will add these two, you will get 100 gram. That means the mass remains conserved in the chemical change. So you can see during the above decomposition reaction, matter is neither gained nor lost. So one example I have explained related to physical change, and another example I have explained related to chemical change, and from both the examples we have come to know that the matter is neither gained or lost. So what we can say? We can say that law of conservation of mass is followed in both physical change and chemical change. Law of conservation of mass is followed in both physical change and chemical change. So this was the first law of chemical combination. Now let us see the second. The second is known as law of definite proportions. So here you can see what this law says. According to this law, a pure chemical compound always consists of the same elements combined together in a fixed proportion by weight. That means if you have to form H2O, okay, then you will take H and O in the ratio 1:2, or you can call it CO2. Let us see CO2. So C and O you have to take, and it is in the ratio 1:2. So in both the cases, the ratio should be maintained while the formation of compounds. Like you can see here, carbon dioxide may be formed in a number of ways. That is by burning coke in air. When coke is burnt in air, you can see coke is in the solid form and O2 is in the gaseous form. So when coke is burnt in air, then CO2 is formed. You can see here CO2 is formed. This is one method of formation of carbon dioxide. Now the second is by the decomposition of limestone or on heating. When limestone is heated, limestone is CaCO3. When it is heated, then it forms calcium oxide, and along with that carbon dioxide gas is formed. So this is the another method of preparation of carbon dioxide. And the third which I have explained here is by the action of dilute HCl on washing soda. What is washing soda? Na2CO3 is known as washing soda. Actually it is Na2CO3.10H2O, but here Na2CO3 is reacting with HCl to form NaCl, H2, and again CO2 is formed. Okay, but in all the three cases the CO2 which is formed, here the ratio of carbon and oxygen is 3:8. So the ratio should be maintained to form any chemical compound. So this is law of definite proportion. Rest laws we will discuss in the next class. Thank you, students.